Association of Old Crows 2023. We are in the booth with Maury Microwave, which now is the parent company of Boonton, Noisecom, Holsworth, and so on. And we're going to get a demonstration here of a satellite link. And Mike Cagney is going to explain us to that. So Mike, why don't you tell us what you've got here for some equipment?
Okay, well, good afternoon. What we have here is a advanced channel emulator, which is designed to emulate the links between ground stations, UAVs, satellites, for different types of satellite orbits. We're signal agnostic, so all we're going to do is set up a link. So, for example, here we have a scenario where we have a ground station in New York, we have another ground station in Colorado Springs, and we have a satellite. We're using a Starlink satellite. And what will happen as that satellite moves across the horizon, we're going to get changing delays and Dopplers and signal attenuation. So if you were in a lab and you wanted to simulate this particular satellite, what will happen if I run this 1,000 times faster than normal, as the satellite moves across the US, we're going to get continuous change in delay, Doppler, and signal attenuation. So we could be in a lab environment where we have a transmit modem connected through our link emulator to a receive modem, and we've set it up as if we have one in New York, one in Colorado, and we're communicating over a Starlink satellite. So it's very, very simple. All I would do is I'm going to connect to the instrument, and now I'm going to run the system. So now, as we run, what's going to happen is the software is going to transmit data in real time to the link emulator. And normally, this is a different setup, but normally you would connect your transmit modem into the input and take the output of the link and connect to your receive modem. So in addition to being able to emulate the RF link between uplinks and downlinks, we can also emulate hardware in the loop impairments. We can do things like amplifier compression, we can add phase noise, we can change the passband and ripple and shape of the transponder. This allows users to fully characterize their systems, either because the satellites are not visible or their signals are privileged. So thank you.
Hi, my name is Matthew Diesner, Business Director for the Maury Microwave Group, and I'm representing the Boonton and Noisecom and Holsworth product line. At this demonstration that we're going to show today, Martin had a demonstration on a satellite link emulation, and we're going to show you some of the measurements that can be made with this link emulator using some Boonton Electronics equipment and Holsworth equipment, the importance. As we showed in the one episode of the demonstration, they can monitor phase and manipulate phase. So on this device over here, what we did is we used the Boonton synthesizer to generate a nice, clean, low phase noise signal. We fed it into the phase noise analyzer to get a good baseline reading on our display. Then what we did is we injected that signal into the ACE box, which then we manipulated some phase, and we can see the difference now in our trace of phase. Phase becomes very important in communications, especially of additive phase noise and items like that to prevent and actually disrupt communications. Another thing that we did then is the ACE box is capable of adding carrier and manipulate noise, so we can do carrier to noise, and also latency or delay measurements. So using the Boonton Electronics sensors, I'm going to point over here. We have a demo aid that's generating a pulsed signal. I have a splitter going into the Boonton Electronics sensors, feeding it again into the ACE box, where we're manipulating some capabilities of latency and carrier to noise, feeding it back into the Boonton sensor. So on our display of the Boonton Power Analyzer software, I have a signal here that is showing the input of the signal and the output from the box. I'm going to ask Michael to turn on some carrier to noise for us. And one of the things that we now see is our output is actually got some noise on the device. I'm actually able to even then do some of the measurements of this. I'm able to do on the display the input signal, the output signal that has noise on it, and I'm able to give a CCDF display showing crest factor of what's going on the actual signal. And again, this is for amplifier performance. Another thing that we can do with that box is timing. And what I'm going to ask Michael to do now is add some latency to the signal. And as we see, as he's adding some delay or latency, we can actually see the input and how much latency we've added. And using our cursor resolution, we can determine the actual delay.